Logarithms with base e are called natural logarithms. Natural logarithms are denoted by ln. For example, ln of 2 means log to base e of 2. You can be able to work out any natural logarithm on your calculator. There's a key in your on your calculator that can help you to do that. So if you go on your calculator on the left, for example, if I want to work out ln of 2, then you should be able to get your answer. There are a few things that I want to discuss here about natural logarithms. In fact, there's an important relationship that I want us to look at. Now, if x is equals to e to power y, now remember this is in exponential form. Suppose I want to convert this to logarithmic form, I will end up with y is equals to log to base e of x, because the base is e and the power here is y. Well, this can be written as ln of x. So instead of writing log to base e of x, we can write this as ln of x. Now, my goal is actually, what my plan here is to try and bring these results together so that we can end up with an important relationship that we can later on use in problem solving. So from the left, we can see that x is equal to e to power y. But from the right, we can see that y is equal to ln x. So what I'm going to do here is, instead of writing e to power y, I write e to power ln x. So what I'm basically saying here is x is equals to e to power ln x. This relationship is in your formula booklet. In fact, in your formula booklet, what I've given you is something like this. You have a to power x is equals to e to power x ln a. And this basically, from laws of logarithm, this is same as a to power x is equals to e ln a to power x, because you can bring this here to end up with the relationship that I have below here. So what I'm trying to say here is this relationship here is the same as this relationship here, and this is available in your formula booklet. So you don't have to cram it. All you need to know is how to use it. And I'll show you how to use it in next examples. Here is a question. Use your calculator to evaluate this. You can be able to do that. So just go onto your calculator, and then this is the question that we have. I think it's better if you can use the fraction button. So just go to alpha y is equals to, and then ln 4. You don't have to close the bracket over ln 2, and you should be able to get your answer. So the answer to our question here is just 2. Here are other questions. Solve these equations giving your answer to 3 significant figures. So what you have to do here is, some of the questions are given in exponential notation, some of them in logarithmic notation. So what you have to do is to figure out what you need to do. Do you need to convert from exponential to logarithmic for you to be able to solve x, or do you have to convert from logarithmic to exponential? So starting with A, what I'm going to do is to convert this e to power x is equals to 2.3 to logarithmic form. So I'll have log to base e of 2.3 is equals to x. This is the same as ln 2.3 is equals to x. Now what I have to do here is to just plug in ln3 in my calculator, find what it is, and that will be my value for x. So if you go into your calculator, just press ln 2.3 and you should be able to get your answer. So our answer will be x is equal to 0.833. Okay, next one, I will convert from logarithmic form to exponential form. So e to the power of negative 1.5 is equal to x. So, and you can work out what e to power negative 1.5 is from your calculator. So if you go on your calculator, second ln button, you'll see e to power something. So negative 1.5. And if you work out that, you should be able to get 0.223 as our answer. So x is equals to 0.223. The next one, we'll do the same thing. So if you go on to converting from exponential form to log form, you'll have log to base 10 of 0.75 is equals to x. So x will basically be equal to log 0.75. As you know, log base 10 can be written as log something. So log 0.75, if you go on your calculator again, log 0.75, and you should be able to get your answer, which is negative 0.125. And then for D, we may have to convert from logarithmic form to exponential form. So 10 to the power 3 is equals to x. So x will be 1,000. Okay, this is some other questions. Without using a calculator, evaluate these expressions. Now, what I'm going to do here is I'm going to use these relationships. The first one is a to power log to base a of x is equal to x. So this is the first relationship that I'm going to use. Another one is x is equals to e to power ln x. Again, this is another very important relationship. Now, these relationships here are actually available on page 4 of your formula booklet. So all you have to do is go on page 4. You should be able to see them, and need to practice how to use them. I'll show you here an example. So A is actually similar to the first one, the first relationship, the one in blue. So what I'm going to do is, I know A is 5 and my X is 12. So my answer will just be equal to 12. That's it. The next one, my A is 5 and my X is 4. So my answer will just be 4. Now the last two questions, I'll use the relationship that's in green. So my X is root 3. So that will just be equal to root 3. And here my X is 4. So my answer will just be equal to 4. That's it. Here is another question. Show that e to power ln x ln 2 is equals to 2 to power x. Now, the relationship that we're going to use here is this one. A to power x is equals to e to power x ln a. Now remember, this is the same as e to power ln a to power x if you use the laws of logarithms, the power rule. This is very important. This is available, this rule is available on page 4 of your formula booklet. So by inspection, when you come up to, we look back on this question, what I'm going to do is to move this x here. So I'll have e to power ln 2 to power x is equals to 2 to power x. And of course, if I use the previous relationship whereby, which is similar to what I have here on the right, that e to power ln x is equals to x, then that means that e to power ln ln 2 to power x, where I'm actually taking 2 to power x as my x, will be equal to 2 to power x. So it makes sense. You know, if you use these relationships that we have here, and these are available on page 4, then it makes sense to say that e to power ln 2 to power x is equals to 2 to power x. I'm now going to look at laws of natural logarithms. So, laws of, these are similar to laws of logarithms. So if I have ln a plus ln b is equals to ln a multiplied by b, ln a minus ln b is equals to ln a over b. And then here's the power rule. N ln a is equals to ln a to power n. So I now want to look at how to apply these rules to simplify expressions. Here's first example. I'm sure that the left hand side is equal to the right hand side. So from the left hand side in this question, I'll have, this is my a, so ln 1 minus ln 50 root of 2, put that in bracket. This will be ln 1 minus ln 2 to power a fifth. So ln1 minus a fifth ln2. Now we know that ln1 is 0. So a fifth ln2, which is just negative a fifth ln2. For B, from the left hand side, so I'll have ln e to power 2 minus ln 8. This is equals to 2 ln e minus ln 8. We know that ln e is 1, so this will be equal to 2 minus ln 8. But 8 is 2 cubed, so 2 minus ln 2 cubed, which will be equal to 2 minus 3 ln 2.